Hello, now we will be doing today multiplexer. Yes, this multiplexer we will be doing, and first of all, we must understand what is multiplexer. Multi, many, and multiplexer is from many to one. This is just a general idea I'm giving. Now we come to the definition of the multiplexer. So, what actually is multiplexer? Multiplexer is a combinational circuit. Yeah, you know that what is a combinational circuit? Okay, which the value of the output will be depending upon the input. So it's a combinational circuit that has maximum of 2 to the power n data inputs. Okay, and n selection lines. So there are n selection lines, and over here you know that maximum of 2 to 2n data inputs. So inputs are more, and the uh, single output line is there. So from many to one it's coming. One of these data inputs will be connected to the output based on the value of the selection lines. Very important. So your whatever is done is based on the values of the selection line. So the selection line is there in a multiplexer. So since there are n selection lines, there will be 2 to the power n possible combinations. Yes, okay, and possible combinations of what? Zeros and ones. And so each combination will select only one data input. That is very important. One data input from many. So multiplexer is also called MUX. Okay, now we come 4 into 1 multiplexer. So this is a block diagram which shows that there are inputs 1, 2, 3, 4 inputs are there, and you have 4 into 1 multiplexer. Yes, and selection line, very important. From down you can see arrow is there, S0 and S1, and output is only Y, that is 1. So 4 into 1 multiplexer are 4 data inputs, I3, I2, I1 and I0, and two selection lines is over here, two selection lines. Yes, S1, S0 and one output Y. The block diagram of 4 into 1 multiplexer is just shown over here, and now we come to the next one. So next what is there, this will come the truth table. So selection 1, S1 and S0 are the select lines, and the output is Y. You have this I0, I1, I2 and I3. Okay, from there you can find out the outputs are there. Now what happens is that the selection lines over here, the output is there. So what actually happens? One of these four inputs will be connected to the output based on the combination of input present at these two selection lines. So based on the two selection lines, okay, the main work will come on. So present at the two selection lines, and the truth table of 4 into 1 multiplexer is shown below. Just see, I'll be coming to the you find in the left side. Okay, and from the truth table we can directly write the boolean function for output. Y is equal to S1 S0 I1 I0 plus S1 S0 and I1. You can see very well from the particular truth table at the left hand side. Yes, okay, so the multiplexer you can see, and then you can see once more I am showing this is in the left. Truth table of 4 into 1 multiplexer is shown on the left side. Fine, so this is over, and then we come to the 4 into 1 multiplexer, the circuit diagram. This is a circuit diagram where you will find the AND gates are there. Yes, you can even find two NOTs are there, and one AND symbol is there. So how do you implement higher order multiplexers? So higher order multiplexers, so let us implement the following two higher order multiplexers using lower order multiplexer. So lower order, you know the order is 8 into 1 multiplexer. You see how 16 into 1 multiplexer. So higher order and lower order. So over here you find that 8 into 1 multiplexer. So you see 8 inputs are there always. So whenever you are implementing 8 into 1 multiplexer, so using 4 into 1 to 4 into 1, so lower 4 into 1 multiplexer, and 2 into 1 multiplexer, so, or lower than the 8 into 1 multiplexer. So you are using 4 into 1 multiplexer and 2 into 1 multiplexer. So we know that 4 into 1 multiplexer has 4 data inputs, you have already seen, and you find 2 selection lines and 1 output for the other. Whereas 8 into 1 multiplexer has 8 data inputs and 3 selection lines and 1 output. So this is the variation. So we require 2 4 into 1 multiplexer in the first stage order to get, yes, to get the 8 data inputs, and since each 4 into 1 since each 4 into 1 multiplexer produces only one output, we require a 2 into 1 multiplexer in the second stage by considering the outputs of the first stage, okay, as inputs and to produce the final output. So we just see this diagram, then you will be able to understand the block diagram. So of 8 into 1, so you can very well understand 4 into 1 is there and another 4 into 1 is there, and you find that 2 into 1 multiplexer is there. So you see that over here the same selection lines S1 and S0 are applied to both 4 into 1 multiplexers. Yes, see in the center you will find S into 1, S1 and S0 is there, so it is applied to both. Okay, and what is happening over here is that the data input of the upper 4 into 1 multiplexer are I7 to I4, this one upper one, okay, and the multiplexer I3 to I0 down, the lower one, the lower 4 into 1 multiplexer. Therefore each 4 into 1 multiplexer produces an output based on the values of the selection lines over here, that is the S1 and S0, and the outputs of the final stage. So this is the final stage, the outputs of the final stage 4 into 1 multiplexer, okay, are applied as inputs, 4 into 1 are applied as inputs, okay, of 2 into 1 multiplexer that is present in the second stage. The other selection line S2, selection line S2 is over here, is applied to 2 into 1 multiplexer. So here you find the particular fact, and now we come to 8 into 1 multiplexer. So if S0, S2 is 0, then the output of S2 into 1 multiplexer will be 1 of the 4 inputs I3 to I0 based on the values of the selection lines S1 and S0 that we have found in the block diagram. So if S2 is 1, then the output is what? Of 2 into 1 multiplexer will be 1 of the 4 inputs I7 to I4 based on the value of the selection lines S1 and S0 because it was in the center. So therefore the overall combination of the 2 4 into 1 multiplexer and 1 2 into 1 multiplexer performs as 1 8 into 1 multiplexer. So it makes 1 8 into 1 multiplexer. So then we come to the 16 into 1 multiplexer. So you find the selection lines there and the output also over here. And how this is done? In the same manner, you see it is divided into 2. How? Let us implement the 6 into 1 multiplexer using 8 into 1 multiplexer and 2 into 1 multiplexer. So see, again the same condition is coming on. We know that 8 into 1 multiplexer has 8 data inputs and 3 selection lines and 1 output. Whereas the 8 into 16 into 1 selection multiplexer has 16 data inputs and 4 selection lines and 1 output. So how we can do that? So we require 2 8 into 1 multiplexer in the first stage in order to get the 16 data inputs. Since each 8 into 1 multiplexer produces 1 output, we require a 2 into 1 multiplexer in the second stage by considering the output of the first stage as inputs and to produce the final output. So this will be clear when you see this diagram over here. So the block diagram you can see and see 8 into 1 multiplexer is over here, and 8 into 1 multiplexer is coming from here, and see S3, S1 and S0 is coming because 8 2 to the power 3. So there are 3 selection lines, and then again it comes to the over here as the 2 into 1 multiplexer. So the same selection lines S2 and S1 and S0 are applied to both 8 into 1 multiplexer. The data input of the upper 8 into 1 multiplexer are I15 to I8, and the data inputs of lower 8 into 1 multiplexer are I7 to I0. Therefore, each 8 into 1 multiplexer produces an output based on the values of the selection lines, that is S2, S1 and S0. Fine. So the output of the first stage 8 into 1 multiplexer and applied as the inputs of the 2 into 1 multiplexer that is present in the second stage, the other selection line S3 is applied to 2 into 1 multiplexer. Yes, and then 16 into 1 multiplexer is easier to form. Yes, if S3 is 0, then the output of 2 into 1 multiplexer will be one of the 8 inputs I7 to I0 based on the values of the selection lines S2, S1 and S0. If the particular thing S3 is 0, okay, then what happens? Then you will find that if S3 is 1, now the condition is 1, then the output of 2 into 1 multiplexer will be one of the 8 inputs, that is I15 to I8, based on the values of the selection lines S2, S1 and S0. Yes. Therefore, the overall combination of two 8 into 1 multiplexer and one 2 into 1 multiplexer performs as one 16 into 1 multiplexer. So this is what we know what is a multiplexer and how the things can be formed with the multiplexer. Okay. So thank you. I hope it is clear. Okay, and just go through this particular video over and over again so that it becomes clear. Any problem, I am ready to help you. Okay, thank you. Yes, you can also join in the website so that you can get clear idea. Thank